I'm Dr. Sharma, and today in this session, I'm thrilled to take you on an engaging journey into the world of biomedical vision intelligence and how deep learning is unlocking health insights which never happened before. Let's begin for the session. So here is what we will cover in the next 2 hours. We will start with the fundamental of biomedical vision intelligence, then explore different biomedical imaging modalities. We will look into how deep learning is transforming diagnostics, dive into key case studies, and also touch upon ethical consideration and future direction. There will be an interactive segment, so whenever you can ask any question from me. Whenever you feel, you can interrupt me. So as we know that there are different methods to acquire information in biomedical study. So, for example, you have heard about magnetic resonance imaging, positron emission tomography, histopathological imaging, ultrasound imaging. Different imaging techniques are uh, dedicated to different kind of information. Suppose if we talk about histopathological imaging technique, then we will dealing with the cellular information, how there is a formation of tissues and cell within the body, and what are the kind of what is the shape, what is the feature of that cellular or tissue region there. And when
Excuse me.
yes,
Ma'am, there is one pop-up in front of your slide. Please click on hide option.
okay, okay.
Hide.
Sure, sir. Sure.
Thank you.
Yes. So I was talking about the different kind of imaging technique. When we are dealing with MRI, magnetic resonance imaging, in that case, it generally giving the information about the soft tissue contrast. CT scan images are basically means are dedicated to get the information related to bone and lungs, and X-ray images for test screening, and ultrasound you have already aware about it for fetal imaging. So different kind of images are having different kind of purpose, and every features is very important and can provide more insight to the in order to develop the very good model using these information. But we human can easily perceive this information by just seeing that what are the any kind of mismatch, or any kind of error is there, or any kind of that abnormality is there. But how a computer understands such kind of abnormality? We will discuss about it, how deep learning and machine learning are efficient in extracting these information, how these model works over the images. So, as what is the biomedical vision intelligence basically? This is the combination of computer vision and medical sciences in order to get information, in order to acquire the information so that we can analyze biomedical images automatically, quickly, and with great precision. Imagine computer interpreting X-ray, MRI, and retinal scan the way radiologists do. So that's the power of biomedical vision. So in order to make it successful, the biomedical vision intelligence, machine learning play a very important or significant role in this case in order to recognize pattern just by visualizing the images. So image processing is the most important tool is here. Before processing any kind of image, or before making any intelligent decision over the image processing methodology we use in order to make the raw data set into an informative data set. So for that, we are going to apply various image processing technique over the data set, whatever we are having with us. Uh, so there are different application of computer vision. in healthcare domain, and that means in order to develop that automatic vehicle, self-driving cars, and many other models. So here we will I will talk about a case study that is related to the machine learning approaches for early diagnosis of Alzheimer disease using data from multimodality of neuroimaging. As I have worked over this particular project in my previous institute, which is National Brain Research Center, I was scientist there, and my main task was to develop the machine learning model in order to diagnose Alzheimer disease. So these are the various modalities through which we can acquire different information from the brain. For example, there is QSM, which is quantitative susceptibility mapping, which is giving the information related to the deposition of iron within the brain. Functional anisotropy, that fractional anisotropy, and gray matter volume. These are the specific information that we can acquire through that DTI by using decision that DTI modality. Then the MRI scans are basically providing the information related to the structure of brain. They are giving the information related to brain atrophy and metabolite. These are the some that metabolite which are present within the brain, and the concentration level is greatly associated with the that impression of Alzheimer within that person. So whenever there are some specific metabolites such as GSH and GABA, the concentration level of these metabolite if false, in that case, that person are more prone to develop the Alzheimer disease. These are some scientific study which have already done by the scientists, but from the study, we want to establish the relationship between the medical science research and the computational research, which we are going to perform using these deep learning and machine learning models. So, means how the AI can work upon the quantitative data, and whether these are validated through the medical sciences also. So in this study, we are considering the information from multiple modality. We will fuse those modality information in order to develop a unrich solution using deep learning or machine learning models. So again, if anybody having that interest in biomedical, so first they have to understand the fundamental related to healthcare. Means in which on which problem they are want to work. So in that case, they have to study about the fundamental related to that particular disease. So here, as I already discussed, that there are different potential biomarkers which are going to represent that whether the person is having the probability to develop Alzheimer disease in future or not. So from these medical sciences research, we are having some that the potential biomarker which are listed in this slide, that gray matter volume in hippocampus, gray matter volume in PHC. So these are some anatomical reason within the brain. So whenever you will study about the brain, you will understand what is amygdala, what is hippocampus. So the volume, the gray matter, or as you all know, we are having gray matter and white matter in our brain. So whenever there is volume, their volume is going to shrink. In Alzheimer, basically, what is going to happen that the size or shape of brain is going to shrink. That the size of brain is getting reduced due to the reduction in the volume of gray matter, white matter, and any means more reason within the brain. So these are the this in this slide I have mapped all those features, and that the red one is representing the decrease in the level of these biomarker is more prone to develop Alzheimer disease, and on the B at the B part with the blue one is representing the increase in susceptibility change in these regions and mean diffusivity. These are some parameters that whenever there is an increment in such kind of biomarker, these are more prone to Alzheimer disease. So this has been acquired through the literature survey that all the research in medical domain specifically for Alzheimer disease. So whenever data set is a very important thing in case of biomedical or healthcare domain. Whenever we are dealing with the when we want to develop a machine learning model over the so data set is going to play a very important role in that. So data set always should be validated and should be clean, should be processed properly. I will give you some that basic protocol which you have to follow in any case whenever you are going to develop a machine learning model for the healthcare data. So the very first is redundancy. There should not be redundancy within the data set. Suppose we are having the data set, and this is that in this table you can see there is a missing person name, and we are having two columns. One is representing whether the person is male or female, and the second column representing is female or not. So we are having entry 1 for male and female for female 0. If think about it, that is just increasing the number of that features within the data set with no use. Because if we are representing, if we consider this data set in a manner, if that is having value 1, it representing that the person is male, and 0 for female. So what we can do, we can reduce, we can drop down one column from this data set. In that way, it is going to reduce the redundancy within the data set as both the column giving the same information to us. So whenever you will deal such kind of data set, you will also come to know there is redundancy within the data set, which we have to reduce to in order to reduce the dimensionality of data set, and you can give more that you can improvise your model more in that. So data redundancy reduction is a very important step in whenever you are pre-processing the data. The second thing is in case of medical data set, sample size is also is of main concern, because you will come to know whenever you are going for data collection within the hospital, you will see that the data for healthy person we are having in a very good amount, but for rare disease data collection is very very tough. So what in that case what you will have, you will having more sample for the healthy class but very less sample for rare disease. So in that case, what will happen? There is a kind of imbalance get created within the data set. And whenever you are going to develop any machine learning model over such unbalanced data, it always reduce the functionality or that performance of the deep learning model. So whenever you are having the data in a manner that there are two classes, one with the very many samples and other with the very less samples. So in that case, what you have to do, you have to first balance the data. Now you will you may ask that how we are going to balance the data, how we can balance, because we are not having the sample size enough which can balance the data set. So in that case, how to deal with the data? So in that case, we are having many solutions. The very first is data augmentation, data sampling, and the third one is synthetic and simulated data generation. So data augmentation, I think you will be aware about a data augmentation technique. Data augmentation in case of imaging data, what we are having that we can rotate an image, we can share the image. In that case, we can create multiple sample from the existing sample within the data set. So there are many methods to augment the data. In case of image processing, I will show you that how we can augment the data by rotating the images with 90 degree, 290 degree, 270, 180, whatever degree you want. You can share the image, you can means extend the image. Yeah, in that way, we can also resize the image so that your model is uh, can be journalized over any kind of images whenever it's going to fix. Then synthetic and simulated data generation, in that case, we will talk about generative AI. Because in generative AI, what we can do by using generative adversarial network, we can develop that synthesize the data from the existing data which you have with you. And in that case, what will happen means the GAN is consisting of two components, that where the one is going to generate the data and the other component is going to discriminate with the data. In order to synthesize data in a manner so that it is very much similar to the true data set. The third is heterogeneity and high dimensionality. So this is also very main challenge when we deal with the multi-model data set, because we are having data set with a different measuring unit. Suppose here in this table you can see that we are having four subjects listed with number 1, 2, 3, and 4. And in the one column we are having the age as a feature, which in what is the unit to measure the age is years: 60, 67, 81, and 79. Now the next column is representing the glutathione GSH, which is a metabolite within the brain. It's representing the concentration of this GSH metabolite within the brain, which is very much associated with the that to know that whether the person is having Alzheimer or not. So if the concentration of GSH is very low, in that case, we can say that yes, person is having an Alzheimer disease. So which feature is more important in this table? If I ask to you, then what you will say, that age is more important to determine the that disease, or that GSH concentration? Okay. Uh, I would like to say that GSH concentration is more important, because age is not the important factor here. GSH concentration is the important factor, because that is associated with the disease, not the age. So we should give more weightage to GSH concentration instead of age in this case. So that's why we always normalize the data set. Whenever we are going to develop machine learning model, we are having plenty of features with us, but with different measuring unit. In that case, what we should do, we should scale down our data within a specified range. So that term is known as normalization of data set. We are having plenty of method by using which we can normalize the data. Suppose jet normalization, mean maximum normalization. So these are some methods using which we can normalize the data within a specified range, so that their unit is not going to get hinder within the development of good machine learning model or deep learning. Now, I just want to discuss that what is the workflow for machine learning model here. We are having raw inputs from different modality: MRI, fMRI, DTI, QFM. These all are modality to measure some kind of information from the brain. Then we perform the second component is data cleaning and pre-process. Data cleaning means whatever we are having the raw data, first we process that data in order to make it informative. So imaging based modality, first we check the image quality, then we will perform intensity correction, image denoising. If that is having any kind of noise, then we will reduce that noise from the image. And the next one is image alignment, because the different, whenever we are going to perform MRI scans, the due to the movement of subject, that the subject can move her or his head within that MRI cabin. So in that case, what will happen? We are having some disaligned images. So what we do in that case, we align those images by using some brain template. There are various brain template which are well known in order to align the image. The next one is image registration. This is somewhat similar to alignment, but registration is basically that you are registering all the image with brain region with the that considered template, brain template. Then, if we want to perform any kind of segmentation over it, then we will do the segmentation also. So these are some listed pre-processing method which we can perform over these imaging data. And then for MRS data, as this is a signal data. So in that case, this is having different kind of processing pipeline. In our lab, we were having the MATLAB based framework, which was known as Kalpana. So, where we are going to process our MRS data. First, we do the quality check, then apodization, water filtering, baseline correction. These all are performed over the MRS data in order to extract the precise information from the MRS data, which gives the information related to the concentration of matter. Then, so after processing the data, we perform the data splitting in a manner that 70% or 80% of the data we utilize to train the model based on the availability of data. If your data is very much means good in number, so in that case, what we can do, we can perform that 70-30% splitting also, 80-20 also, 90-10. But when you are having very less data, in that case, what we do, you have to perform data augmentation or oversampling to the data set also. So once you split the data set into training and testing, what we do, we perform feature extraction. We extract the features from the data. So if we are having images and we want to apply machine learning model here, in that case, what we do, we will apply image descriptor over the images in order to extract the information. Whatever the information, that can be average or mean, mode, means there are different kind of descriptor with for the different kind of imaging modality. And after extracting feature, once we extract the features can be in a very vast number, out of which we want to perform the training of the model over the selected feature, which are very significant, means which is having more much significant contribution in order to give the decision. So feature selection, there are various methods to perform feature selection, such as ANOVA test, chi-square test. So in that case, your statistical analysis is come into picture. Statistical model we apply in order to perform feature selection. After that, we standardized or normalized feature vector as we discussed earlier, and then we train the model with this training model. Once your model is get trained, that the upper part in this figure is representing that model is already trained with the machine learning algorithm, and we are applying that, we are giving the extractive feature and associated true label with that in order to see that the machine learning model is get trained over the data. And after that, we will apply this trained machine learning model over the same feature extracted from the test data which has never seen by your trained machine learning model earlier. And then we analyze the performance of this model by comparing the predicted label and the true label for that test data. So there are various methods to compute that the performance of machine learning model. That I think you all have heard about confusion matrix, ROC curve, and statistical analysis. Various statistical analysis we can perform. What is this confusion matrix? You should know about it, and ROC curve. Why these are important? So it will give more insight about the performance of machine learning model. So confusion matrix is basically a matrix that give information that how many samples are truly classified and how many samples are misclassified. So this is a matrix which gives you information related to accuracy, precision, sensitivity, and F1 score. Information related to the performance that related to the developed machine learning. So this is the architecture, how we can distribute it, how we can classify a machine learning algorithm. The very first is traditional machine learning algorithm and deep learning, because deep learning is a part of machine learning algorithm because it's a component of artificial neural network. Traditional machine learning is further classified into three: distance-based, gradient-descent-based, and tree-based machine learning model. And deep learning is divided into two: transfer learning and learning from scratch. I think you will be aware about transfer learning. What is transfer learning? In case of deep learning, we will discuss in further slides also. And learning of a model from scratch. And then transfer learning is further divided into feature extractor or fine tuning model, and where fine tuning can be further divided into layer wise fine tuning and layer freezing. So these are the different method in which we are going to train our model. So this is the difference between traditional machine learning and deep learning. In traditional machine learning, we are having the input, we extract the features from the input, and then we train our classification model over the extracted feature, and then we will give the output. But in case of deep learning, what is going to happen? That feature extraction stage and classification are merged. We are not having any kind of external feature descriptor over the input. That it there is the representation layer within the deep learning model, and that it's going to extract or it's going to extract the information that from the given input automatically by itself, and then it gives the output. It learn automatically from the given input. So I think you well known about it. What is supervised learning, unsupervised learning, and reinforcement learning? This is the broadly classification of machine learning, how it works. When we are having that, when we that what will be the output for the given input. If that is the case of supervised learning, we are having well annotated data in the case of supervised learning. In case of unsupervised learning, we are not having idea what will be the output for the given input. We just learn from the features we observe. In that case, by observing those features, we grouped the given data. And in reinforcement learning, is a learning where machine get trained through trial and error method. Machine learn from its past experience and explore itself that all possible state and determine the ideal behavior. So this is the categorization of machine learning on the basis of that what kind of problem you are going to solve. You can see here that supervised learning get categorized into categorical target variable and continuous target variable. Based on target variable nature, we will basically divide whether this is a problem of classification or problem of regression. When we compute some value in that case, means it means you are having the target variable is of continuous nature. We want to calculate some prediction value there. We are not going to group into class. Class become categorical target variable. So whenever we are going to classify the data, then this become the problem of classification where we having output in the term of classes. But when we are having the output in term of value, that become the problem of regression. And based on classification and regression problem, we decide that what kind of algorithm we are going to use. And yes, in this way, this is the classification of machine learning type. Yes, this is a very basic model that how machine learning works. We are having training data, then we extract the features from all these input, and then we train our classification model over these extracted feature. Whenever the test data come, if we will extract the same feature from the test data and from and put into classification model, and based on that learning, it is going to give the output in terms of classes. So what happened in deep learning workflow? We are just having the training data. We feed that data into deep neural network where that is consisting of various layers, and it learn automatically from the given input and give the output as per the uh, learning from the input. So this is the deep learning model, how it works. As you know that neural network in deep neural networks is the way that it's consisting of various hidden layers between layer, and these layers are basically going to extract the information related to with the edges, texture, and then combine those low level feature into represent the mid level feature. Then it's going to combine those mid level feature into get the high level feature. So that is the representation that works on the face recognition. The very first patch is representing the information or that feature extracted in term of edges, blob, and texture, and then it's going to combine into eyes, nose, ears formation, and then these combined information that this layer further combine and give the information in term of that somewhat faces, raw faces. Yes. So whenever we deal with the images, we always and deep learning. In that case, we always talk about more focusedly on that convolution neural network. That how what is the convolutional neural network? Convolution neural network is a kind of deep learning network which is having many layers. The very first layer is known as convolutional layer. The second is pooling layer. Then we are having activation layer also, and then we are having such kind of arrangement in different manner or different numbers, and then the last layer is fully connected layer, and after that in order to get the probability we combine the softmax layer. So convolution neural network, how it works. Suppose we are having an image. We generally, in case of that during the CNN application, we divide this given image into overlapped tiles. You can see here that when this images get converted into tiles, so all these tiles are overlapped. Why we consider overlapped? So that there is no any kind of information loss by this processing. So that's why we generally consider overlapped image tiles. So we divide that the given image into overlap tiles. After that, this is the working arrangement of CNN, how it works. I think many of you have that get the idea that how the image filtering operation works in image processing. So we converted this original image into image style. You can see there. So this is the image style. As this is a colored image, so that is having the three component: red, green, and blue component. So corresponding to each component, we are having filter convolution that are present into convolutional layer of CNN of CNN. So what is going to happen? You can see here that the zero are appended on the boundary of these image tiles so that whenever we are going to process the data by applying filtering operation, it not going to reduce the size of these tiles, or the original image is not going to reduce the size of original image. So that's why we are going to append the 00 at the boundary. So you can see here that we are having three filter, and these are the red filter is going to apply over the red component of the image tile, green one is over the green component, and blue one over the blue one. So in that case, whenever we are going to applying these filter over the images, then we are introducing that we are adding a bias also. And here we are going to perform the dot product. By applying these, we are going to replace the central value with the value we get after applying this filter over it. So in that case, we are going to shift the filter with a step which is known as stride value. That may be one or two, whatever stride value can be there, but we generally keep it as one. So after that, once we get that resultant filtered that image feature map, we call these as feature map. Then we apply activation layer over it. What is the what is the basic idea that why we introduce activation layer? Activation layer is basically introduce non-linearity within the convolution neural network performance, and ReLU as this is the activation layer which work upon feature map in a way if the value having positive value after applying that filter over the image type, then it will keep them as it is. If there is any kind of negative value, it replace it with the zero. Then there is a role of pooling layer. Here we have applied pooling layer. You can see here that the size of pooling layer is 2 by 2 here, so that whenever we are going to apply a max pooling over it, it will consider only the maximum value and it replace that corner value with the maximum pixel value there. So in that way, it reduce the size of images, and it basically the agenda behind the pooling layer is to uh, that why we are going to perform pooling in order to reduce the dimensionality, and also in order to make the your model generalize with the in spatial domain. So that means whenever wherever that region of interest is present, it can locate that. So this is the main working behind the CNN network. So as I'm discussing the problem of classification here, so classification can be done in a two manner, that binary classification when we are having only two classes, and whenever we are having more than two classes, that kind of classification is known as classification. That as we discussed and how the classification model works, we divide the data set into training and testing data set. Testing data is further divided into training and validation set. Uh, After that, during the training, what is the actual metric by looking which we are going to train our network again and again? This is the loss function. Whenever we are generally computed the loss function between the predicted and the true label, and after that, if that error, that loss is very high, in that case, we are going to train our model until that loss is get minimized, or means up to some acceptable limit. So in that case, means here we are considering cross entropy loss as the loss function here for this problem. So these are the some different kind of evaluation metric as we already discussed, that confusion matrix. This confusion matrix is representing true positive, false negative, and true negative. And again, means it's very important to analyze the results here. Because in confusion matrix, what happened? Uh, it's very important to determine that which is of more interest for according to your problem, true positive class or true negative class. In medical domain, what will happen? Suppose we are having two classes, cancer and non-cancer. If a model is giving in a way that it going to predict cancer as a non-cancerous. One model is here that is going to predict cancer as non-cancer with an accuracy of 75%. Listen me carefully that your model, there is a model one which is representing, which is predicting cancer as non-cancer with 75%. And there is another model which is representing non-cancer as cancer with 74%. Which model do you think is better? Okay. So it's very important whenever you are dealing with the data. So kind of problem. Yes. So you will have to be very careful in determining whether your model is performing actually good or not. It's very important that if a model is representing a cancer as a non-cancer, means that model is not good. Either is having more accuracy, but it's giving more. It's very sensitive to for anybody that it's representing cancer as non-cancer, because other one non if it's representing non-cancer as cancer, it's okay, because after performing screening, it we will definitely come to know that the person is not having cancer but predicted as cancer. But if person is having cancer actually but and predicted as non-cancerous, so it become very bad situation for that person. So we always have to look into the matter, means the problem what we are dealing. So in the study, using the data set which we developed in our lab, we process the data and then we extract the features using some feature extraction method, which are listed here. That this is the literature which we have done over the earlier studies. They have used Shallu transform, contrast correlation, and shape analysis, GLCM. These are some image processing techniques through which we can uh, uh, extract the some features from the data. And yes, this is the feature selection method. As I discussed with you earlier, that there are feature selection is very important, because sometimes very less number of significant selected feature can provide better result, as compared to that you are considering all the features in order to train the model and then it giving the same information or mean the accuracy with the same result. So in order to make your model computationally efficient, that feature selection is a very important step which you have to perform. So there are various different method to perform feature selection, filtering based, that recursive method of feature selection, and some that selection that yes, I forgot the name of that selection method. So, which means we just consider one feature in order to train the model. If the model accuracy is going to deteriorate with the adding of second feature, then we remove that feature. Then we consider another one. And if the performance is going to enhance, we keep that feature. In this manner, we are going to selecting the features in order to train the model. So there are these are the method which is time consuming but giving the very good result for feature selection. Yes, that the name of that selection algorithm is record based. So this is the tree of feature selection algorithm which you can opt in order to perform feature selection based on the distribution of data set, what kind of data you are using. So if I discussed that filter based method is further divided into statistics based, mutual information based, and the statistics based are considering that the student t test, Fisher t test, chi-score test, Laplacian score, heat map, relief map. So there are many more methods to perform feature selection which you can introduce in your research, because you don't know that what kind of feature selection method is appropriate of what kind of data. So it give more insight to you in order to explore the research domain in side of healthcare. Yes, and this is the feature scaling or feature normalization, feature standardization method, which I discussed earlier. That there I have listed five features here, five feature scaling method: mean max normalization, mean normalization, Z-cause standardization, decimal normalization, and unit vector normalization. For this particular data set, which we consider, Z-score standardization performed very well because that make the data unitless, and it keep the mean with the value 0 and standard deviation with value 1. However, mean max normalization is giving the range to the data is from -1 to 1. So in that way you can consider any of normalization method which is suitable for your own data set. Yes. So further means we have studied over the multi-model data that to develop the machine learning model in order to diagnose Alzheimer's. So there are various fusion method also. Feature level fusion means from M1, M1, M2, M3 up to N are representing the modality which we are considering here. Then we are considering each feature F1 from modality M1, F2 from modality M2, and in this manner F1, Fn from modality N. And then we combine all these features in order to train our model. The next one is the second is decision level fusion. What we are doing in this decision level fusion, how we are going giving the final decision over the data which we are considering. In this case, what we are doing that we are extracting features from each domain separately, but we are developing machine learning model, separate machine learning model for each modality. Suppose for M1 modality, we developed SVM model, which is giving best result for modality 1. So in that case, whatever the decision provided by SVM, we are considering the decision of that particular model. Then for modality 2, suppose for modality 2, SVM is not working good. In that case, what we are considering? We are considering that decision tree is a very good model for this particular modality. So in that case, whatever the decision provided by decision tree for modality 2, we are keep that decision. So in this manner, we are fusing their decision in order to make final decision. And when we are considering that decision from each modality, that final decision can be taken on the basis of majority basis or average basis, whatever the way uh, means anybody can want to consider. So, and the next one is hybrid fusion. In that case, what we are doing, we are considering for modality 1 and modality 2 feature, we are performing decision diffusion. However, for rest of the modality, we are performing feature fusion. And after that, from the decision fusion and from the feature fusion, whatever the decision we are having from these two fusions, we again that final decision we are considering from their diffusion of their sorry fusion of their decision. So in that case, this is the hybrid fusion model in which manner we develop our classification model. So there are plenty of way to play around that how you can develop your deep learning model on your own data set in order to get the best performance. And there are some specialized fusion rules also, as I told you that majority voting is the one, and average voting is the one. So there are different specialized fusion rules also. For final fusion, you can introduce different other machine learning models. So in this case, you can see here that modality after extracting feature, we make intermediate classifier, and after getting information more from each of these modality, then the final decision is taken by the SE. So in that manner, we can develop our machine learning model. So the conclusion of this study was that combining information from multiple modality can improve the performance of each modality, and sample size, heterogeneity, high dimensionality, fusion strategy are playing very significant role in case of multi-model data fusion. So that it's very important to keep in mind what to fuse, when to fuse, and how to fuse. So every that decision at every step is important and may give rise to different direction to your study. So yes, this is the framework which we developed in lab that time. That is AI-based CAD system for ED early diagnosis. This is developed over the MATLAB. So that is the framework or GUI that user interface which we developed during that tenure using considering that multiple multi-model data in order to perform feature scaling, then feature selection panel, how we can select the features. So means I'm giving an idea that you can develop your own framework also by using these machine learning model and by combining with your GUI interface. So, so this is the one. This was the one study. Now I want to introduce that the concept of this explainable AI also, which is very important because as we know that deep learning models which you are considering are basically a black box. We don't know clearly how that particular model gives that particular decision. So on what basis they are going to decide. So in order to give clarity to the decision, we now the concept of explainable AI is come into the picture already. So they so, so in the study, what I did that I have introduced that explainable AI using Shapley library and Lime library. These are two libraries which you can use in order to get more insight about the performance of the developed machine learning model, means how they are taking the decision over the given data set. So this means this is a one picture where Shapley analysis is applied over the collected data set, where you can see here we were having three classes: healthy, mild cognitive impairment, and Alzheimer disease. Mild cognitive impairment is basically the stage which is between lying between the healthy and Alzheimer disease patient. So this is the initial stage to develop Alzheimer. So it's very difficult to classify a subject means into MCI and Alzheimer disease. So there are these are the these you can see here I have listed. the features which are contributing in making the decision. Here you can see that feature importance responses for AD. Total number of feature was 68, and out of which means these are the with the left ventricle, white matter hypointensities, right ventral DC. These all are feature out of which these features are contributing very importantly towards one particular disease. From here, you will come to know that which is the significant, which can be significant biomarker in order to represent the AD class, MCI class, or healthy normal. So these are representing the importance of feature contributed more in determining which class. So here you can see that left hippocampus size get reduced in case of Alzheimer's disease. So you can see that this is the medical science which is saying that left hippocampus is representing the that whether the subject is going to develop Alzheimer or not. So from stats also, from that computational method also, we are come to know that yes, exactly, left hippocampus is playing a very important role. So it's a significant biomarker in diagnosing and MCI and Alzheimer disease. So these explainability are very important to determine new biomarker for a particular disease. Here you can see that again this is the SHAP analysis which is giving the mean average. It is representing for all the class collectively. Means you can see here that the very first feature brain segment of volume 2 ETIV, that this is the feature that is having much more importance in case of class 1 which is AD. However, somewhat less in case of healthy old, and similar to that healthy old in for MCI also. So you can see here that which particular feature is important or playing significant role in determining which class. So explainable AI is very important to introduce. So whenever you are going to develop a model, then apply these libraries, Sharplay and Line, in order to get more insight about that develop model. So we can perform that comparative plot also for all these that means if the patient is having ID number 4 and 18, that responses means predicted responses MCI, and how that these are that what kind of behavior these are showing. So in this way, if the two subject from the same class is having same kind of waveform, so you can come to know that yes, exactly, these kind of behavior or pattern are shown by this particular class subject. So in this manner, you can make more analysis by using explainable AI. And this is explainability using line. This is another library where that is representing whether that function means subject is not AD. So in that case, that blue one is representing positive contribution towards the that not AD. That subject is not Alzheimer. But yes, GSH concentration is negatively means if the GSH concentration is decreasing, in that case, that the person is having Alzheimer disease and more prone to AD. So in that way, you can make analysis using explainable. So means I just want to show that interactive session or that, that collab, Google collab. Yes. Are you able to see that my screen?
Yes, ma'am.
Okay.
Ma'am, I have a question.
Yes, yes.
Ma'am, when do should we use sharp and when to use lime? Like, what's the difference in these two techniques?
Okay, very good question. That sharp and line are basically you can apply for any kind of machine learning model, but line specially whenever you are performing over the image data set. So in that case, you have to apply line library. You have to use line. Shapley is not providing insight related to the imaging data. That is giving the that explainability over the that data in the CSV format or that numerical data. So for numerical data, whenever you are having feature in term of numericals, means that numbers. So in that case, you can apply sharp as well as line, but line can also give explainability over the images, but not the sharp.
Yeah, thank you, ma'am.
And one more means I want to discuss if you want to get more explainability over the image data set. Now there is one more technique which is grad cam. Grad cam is another way by applying which you can determine that explainability over the images. It's going to represent that the reason which compel the model to give that particular disease. Okay, so yes, I just want to show you that there is one more study, case study. So before that, before starting, I just want to show you what kind of data set I have. Yes. So this is the data set which is basically related to lung cancer, and I am provided with very raw data. You will see that this is the sample of 10 cases. These are the scans of 10 subjects. Are you able to see that the folder here, 1 to 10? If I open it, you will come to see that I am having these files. Okay, so this is the files associated with the patient one, or means you can say subject one. And when we are going to open it, you will come to see that there are some files. These are DICOM files. You can see the type of these files, DICOM files, right? So whenever we are going to consider the scans of, in case of medical domain, that this is the most common format in which we are going to save the images or scans, right? So this is this that CT scans of lungs, and these 66, 67, 68 up to 92 is representing the slices of that lungs, means that is giving the taking the scan in term of slices. Okay, I will show you. This is for the very first for right lung, and the second one is for left lung. So in order to open these files, I have one software because yes, from here you will come to see that it is the picture which is related to cancerous or non-cancerous images. So this is the CT scan of lungs, right? From here, what you will see that the data set we provided with, you can see that we are having the one Excel sheet there. Yes. For this, the very first case, SC001, as we seen earlier, that for the very first folder, it is giving the information, the presence of cancer, X1, Y1, Z1. These are the spatial coordinate which representing the presence of cancer there. Within the slice, the Z1 is representing the number of slice. That on 13th slice, this, at this position, and this position of X1, we are having cancer according to this data. So you will see here when I am going on the 13th slice. Yes, at this 13th slide, at this location 134 and 220 x coordinate, you can see here that x coordinate are changing there at the very left pane. In the left side, you can see that if I'm moving the cursor, that the value of x and y is also changing. So from there, from here, I'm on the 13th slice, and when I'm moving this cursor, you will see that x coordinate is 134 and y is at 280. There is that is showing the presence of cancer. So this particular feature is representing the presence of cancer, and then we will save this picture, export this particular image, and save it as into any folder. We can create, make new folder, and yes, data set. And this data set, what we are doing, we are creating our own data set. We are creating and we are that saving that particular image into name with the name cancerous image and non-cancerous image. At other slides, whenever there is no visibility of such kind of spot there, you can consider it as non-cancerous image. So in this manner, we can create our own data set with the given data set. So this all process comes in the domain of pre-processing. Understood? So in this manner, I have created a data set, and here you can see the Google Colab. Yes, I just built this model, and this is working over the transfer learning method because I'm considering the pre-existing network and just fine tune that network over my data set. I will show you that these are the libraries which we imported in order to develop this model, that input, lambda, dense layer, flatten layer, average pooling we are performing. Dropout. Dropout is a technique which we perform, which we apply in order to reduce the overfitting within the network. From TensorFlow, and these are the Keras framework we are using in order to develop this model. And Keras framework we are importing model. So here we imported the model VGG19 from NestNet. From these library, we imported NestNet Large, NestNet Mobile, whatever the model, pre-existing model you can use. From after importing these libraries, we just mount the Google Drive because my data set is already that, saved in the Google Drive. So I will mount that drive in order to fetch the data. So it will ask my permission that in order to connect with the Google Drive. You can see here Google Drive is get mounted over it. You can see by from here also G Drive. And in G Drive, my drive, I am having this data set. One folder is with the cancer and another one is with no cancer. And if you further open it, you will find that there are the images which I recorded, which I that created or captured using this that a DICOM viewer Radiant software in order to make my own data set by just with considering with Excel file which shared by the dataset provider in order to create the dataset with the cancerous images and non-cancerous images. So after importing libraries and after mounting Google Drive, I just I have defined the image. All the image have been resized with the image 224 by 224 because the CNN which we are going to use is considering the size of images in this manner only in the multiple of two. So that's why we have resized the image 224 to 224. Here I'm considering very small number of epochs because otherwise it will take so much time in order to train the model. So just to visualizing purpose, I'm using here 10 epochs. And this is the best size which I considering is 32. Means at one epoch, how many images are going to train in one batch? Means I have created 32 batches. So after that, after defining the path, means that is the path for cancerous images, which is saved in folder with the name cancer. And this is for the path for the non-cancerous images, which are saved in no cancer folder. So after giving the path, then I will yes, I'm visualizing whether the dataset is loaded or not. Means yes, first five cancel files with the name 0001, 002, you can verify from here that whether the data is correctly mounted or not, right? And total count for the cancerous images is 147. However, the count number for non-cancer images is 179. Then we are storing the label. Then means that the label associated with the image. The labels we are considering in a way that those images which are saved in cancer folder are named with label cancer, and the non-cancerous images are labeled with non-cancer. So in this manner, we are labeling our considered images. And after that, for visualizing purpose, I'm loading the data. And for visualizing, I have been used in order to read that images. I have been used OpenCV library here, and you will see that it will show that cancerous and non-cancerous images with the title CT non-cancer and CT cancer. So, so this is basically the loop, the length of which is equal to the cancer files, means the files which are present in the cancer folder. So we are having 147 files, so it's going to label each cancer file as cancer. Meanwhile, you may ask question or query if you have. Yes. Yes, means I'm waiting for it. Meanwhile, we can discuss the data set for which you can explore more. Uh, this is the data, this is the one site which is named as databiox.com. So this is the site where you can found various kind of data set which you want and for which you want to provide AI solution. These are all validated data and they have publicized their data in really good journal also. So means these are validated, well annotated data set which you can utilize for your own study. I'm just representing that how these data set you can download. Yes. So this is one of the data set which is related to the histopathological grading of breast cancer in invasive ductal carcinoma. So these are four classes of invasive ductal carcinoma in which you can see that there are four classes which you can, if you develop your classification model over these images, and this is another one which is having colorectal cancer histopathological grading, where grading are provided grade 1, grade 2, and grade 3. So means if you want to differentiate between the different grade of the cancer, you can utilize these data set in order to train your model. So they are having that video-based data set also, ultrasound images data set also, that COVID-19 data set also. So if you want to explore more data set in healthcare side, you can go through this website. And yes, if you want to download a data set, in that case you have to fill this form and they will send you a verification mail, and after that you will be able to download the data set from the provided link within your mail. So and also that the Kaggle is also giving very good provide very good data set through which you can work upon you can develop your prototype of such features. So means there are various way if anybody want to work over these data. Yes. Yes, you can see here that cancer CT scan images have been visualized. Sometimes what happened that there is no folder with the images, so in that case it will show zero images, total count as zero. And when you are going to run this patch also, it will show nothing to you. So you will come to know that yes, no any kind of images uploaded and the path is not provided correctly. So, yes, after that, mm, yes. So this is the this script is going to basically normalize the images. As you know that means we are having the images captured with different resolution and saved with a different number of bits. Suppose we are having 8-bit images. So in that case, how many gray shades are there within the image? That lies from 0 to 255. So means that all the pixel intensities will be in that particular range. And we are supposing that yes, the images are saved in 8-bit only, and we are normalizing those pixel value within the range from 0 to 1. So to normalize those images, we are dividing it with every pixel within the image with 255 value. Then we are going to split the data into training and testing for both type of images. Training and testing splitting in a way. Here you can see that test size is equal to zero point 0.2, which is 20% of the provided data set. So here you are splitting the data into 80 and 20 ratio. Similarly for cancer and similarly for non-cancerous images. And once you are going to split these data sets, then you will concatenate the explain, extest with their associated labels, and then you will categorize those label either zero or one, because we are having two classes here, cancerous and non-cancerous. So zero will be assigned to maybe to cancerous and one maybe to non-cancerous. So in that case, if we are having multiple classes, then we will make label them 0, 1, and 2. So in that case, we are basically categorize the classes here. Uh, yes. So this is the plotting of X. X train and X test here, and then we are going to building the model. As I told you that we are performing transfer learning here. So what we are doing, we are considering the weight of nestnet model as imagenet. Means that model is already trained on imagenet dataset, but yes, top layer is false because we have to categorize the dataset into two classes only. However, imagenet dataset is having 1000 images. So in order to utilize those trained weights, we are using NestNet large and weight with the ImageNet. Uh, because transfer learning model are basically developed on with the thought that you not need to uh, they train your model from the scratch, as it takes very much time also in order to acquire the same kind of information, suppose texture, blob, edges, corner. So in that case, what we are doing, we are going to use the weights of it, that the nestnet model already trained on the ImageNet data. And output layer means we have provided flat earth, we have introduced dropout layer in order to reduce the overfitting, and then dense network, and the last we appended the softmax layer because we want the output in term of probability. And then that yes, we discussed that we consider here that categorical cross entropy as a loss function, and optimizer which we are using Adam optimizer. Adam optimizer is a very good optimizer in all sense, as it is having the essence of both RMS crop and that other optimizer also. So it leverages the benefits of both those optimizer. So that's why we generally means consider Adam optimizer. However, you can change optimizer here also. Means you can use this gorilla troop or optimizer. So you can replace these optimizer also in order to see that whether your model performance is get improvised or not. And then, yes, this is the image data generator because this is basically for augmentation of training data set where we are rotating the image, shifting the image width and height with the value zero point 0.2 horizontal flip. But you have to be very, very careful again. Means you are not, you can't perform these kind of data augmentation to any kind of data set. First, if suppose we are dealing with that numerical value data set, then in that case, what will happen? It will, if we perform rotation over 6, it will convert it into 9. So it's going to that manipulate the information. So you have to be very careful whenever you are dealing with the data, whether such kind of data augmentation is applicable on that particular data set or not. So you have to be very careful in opting any kind of data augmentation technique. So this is the model summary, means that is representing the architecture of NestNet model, means how many layers are there, how many parameter which we are going to train here. So at the last, it's going to summarize that trainable parameter, non-trainable parameter. You will see that you will see. It's a very large model developed by Google, and it is consisting of two units, um, normal cell and reduction cell. Normal cell is going to retain the image size, however, reduction cell is going to reduce the size of it. Um, yes. So the total number of parameters are 85 lakhs. Sorry, means that is having the size of 325.44 MB. However, the trainable parameter are just 1.51 MB and non-trainable parameter are 323. Means we are going to train only these number of parameters. However, that is consisting of so much parameters. So we are means that reducing the computational cost in this case and making the efficient if it is giving the good in results within the these such kind of trainable parameter, then it will be good to opt such kind of transfer learning method. And yes, then yes, then we are going to apply we are going to train our model by applying this function model fit over the trained augmented data set. And then you will see that it will going to train the data set by running the epochs. As we decided the 10 number of epochs, so it will it will train for 10 epochs and it will take time. Once it will get trained, then we will save the model, uh, and then we will also save the weights of that model so that whenever we want to use that model in order to make prediction, no need to train that model again. We are just going to load those weight within the model, and then we can see the performance of that saved model over the test data. And after performing means after training of that model, we will predict that whether the model is performing good or not. You will see that the result will be in this manner. As we are considering here only 10 epochs, so it's not going to provide a very good result because it should be trained for at least 100 500 epochs in order to make that the model very efficient or that very trained in order to diagnose the images. So yes, you will see here that this is the 100% non-cancer. In this manner, the result will be there. That means it is 100% surety that this particular belongs to non-cancer class. And in this case, that 75.05% with confidence that it is having cancer. Means this is basically the probability with which it's saying that this particular image is associated with the cancer. So in this manner, you can see the results. Yes. After performing these test analysis, means after performing these analysis over the test, what we will do, we will perform the confusion matrix. What will we do? We will perform confusion matrix. When we are going to plot the confusion matrix, so this is the way means how you can plot the confusion matrix. The that is representing the true label, non-cancer and cancer. And this is representing the x-axis is representing predicted label cancer and non-cancer. As you can see, how can we read a confusion matrix? Means that cancer, 27 images are predicted as cancer here. However, because the true label is cancer and predicted as cancer. However, true label for these images is cancer, three. Three images are the images for which true label was cancer but predicted as non-cancer. Similarly, 28 images are non-cancerous actual but predicted as cancerous here. And 8 images which are non-cancerous are truly predicted as non-cancer. So this is the confusion matrix using which we will come to know that what are the performance of our model. And these are the metric classification report, means what is the precision, what is the recall, F1 score, and support. You can see here that the 0 and 1. And from those analysis, from the upper analysis, you can easily find out that yes, cancerous images are very well diagnosed or very well classified here, right? So that's why the sensitivity recall is 0.90% is here for the cancerous image, which is represented with the zero label, right? And so means model is performing good, but what is the situation is same for class label 1 also? No. This time recall is having 0.22 value only. It means your model is more sensitive towards cancerous images and very less sensitive towards the non-cancerous images. That is representing your model is not performing well, and accuracy is also very low, which is 0.53%. And because we are considering a model good when it having at least 50%, but 53 is not a good number. And side by side you have to know that you have to ensure that sensitivity should be very high for equally for all, both the classes. Means that number may be 0.89 for zero class for zero label and 0.94 for one label. Such kind of difference is acceptable, but not this drastic difference. 0.90 for zero but 0.22 for one, right? So in that case, you have to analyze performance of your model by your own. And these are the plot of the model accuracy for training and testing data set. As means the number of epoch is very less, which is 10 here. So that means you will not get to know the very good that these should be these two training and testing lines should be overlapped with each other in term of accuracy. Similarly, accuracy opposite to accuracy is a loss, so that kind of curve should also be smooth. There is very much height in these. So this is the way, and the very important thing is ROC curve. So whenever you are going to develop any classification model, ROC curve is playing very significant role in representing the performance metric. So recall is basically the curve between sensitivity and specificity. So if sensitivity is low, which is also known as recall, then this why the performance of this is very poor. The area under this curve is very less, it's 50% only. So ROC curve, through ROC curve, you will come to know whether your model is performing good or not. So this is all about that how you can work over these models in healthcare domain. And yes, I just want to discuss what can be the future implications of these studies. That yes, self-supervised learning is very popular nowadays. Means you have to develop model in a way that they are not much dependent on the labeled data set or that all the data set on which the model is already trained, right? So that should be in adapted in nature, adaptive in nature. It should be adaptable, and it should be in a way that it's going to supervise itself. Okay. And the second is digital twinning. This is again a very emerging domain in this case, that if you are able to create twin of any person, means in digital twin of any person, so that we can determine that what kind of problem they may encounter in future. So you can work over these also, because there is a misconception always. Means what is digital twin and means AI, how these two terms are different. AI is part of digital twin. Means whenever you are going to create a digital twin of some process, of some system, in that case, AI is playing a very important role in decision making. Nothing else. But yes, this is the important part of digital twinning system, but not AI. Then the third is federated learning. Means how federated learning is good in case of healthcare domain nowadays, because hospital data is very sensitive. Nobody want to that share the sensitive information of their patient, right? So federated learning is a concept in which they the hospitals use your model locally, and your model is trained over their data set without sharing of that data set. Means your model get updated over the new data set of from that local the data set of that local hospital, but they are not sharing the patient data with the owner of that model, right? So in that case, this is a concept where means the hospital are contributing in research without sharing their own data. Understood. And the third is quantum machine learning model. Means if, as you all know, that quantum machine learning is a very emerging topic nowadays, and it is based on means quantum mechan. It is based on quantum mechanics, right? And where you can use the concept of quantum mechanics in order to develop your machine learning model. So these quantum mechanics, these are basically based on superposition and entanglement, right? To process information in a new way, and it reduces the computational cost dramatically, right? And without compromising with the accuracy, because these are very very fast quantum models. So you can go for quantum machine. So this is all from my side. If you are having any query, then please you are free to ask. And thank you for this session.